Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners, and welcome to today's natural sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are wrapping up our term now, right? We are wrapping up the knowledge area, energy and change for our grade 9 and term 3, right? So in today's topic, we'll be looking at the cost of electrical power and specifically looking at the cost of power. Now, without wasting time, let us look at our lesson objectives. Now, remember that this is what we need to achieve by the end of the lesson. So when this lesson ends, we should firstly be able to define electric power as the rate at which electrical energy is supplied. Are we together? We need to be able to define electrical power as the rate at which electrical energy is supplied. Also, we need to be able to state that electric power is measured in units called watts or kilowatts, right? So the electrical power is measured in units called watts or kilowatts. We also need to be able to explain that all electrical appliances use electrical power to work, right? Each and every electrical appliance needs electrical power to work. Also, we need to be able to explain that the power rating of appliances can be determined by looking at the back panel of the appliance, right? So meaning if we're looking for the power rating of an appliance, we need to look at the back of of the panel of the appliance, right? Also, we need to be able to state that 1 watt of power is equal to 1 joule of energy supplied in a second, right? 1 watt of power is equal to 1 joule of energy supplied in a second, right? And also we need to be able to explain that consumers pay for the quantity of power they use, right? They pay for the amount of power they use. And lastly, we need to be able to explain how to calculate the cost of electrical power used, right? So now all this information is found under the CAPS document on page 76, right? So as we move on with our lesson, I would like for you to take out your notebooks, right, so that you're able to write down each and every important point about this lesson. Are we together? Right. So now let's move on to our pre-knowledge, right, which are some of the topics that we have covered in the previous grades and also in the same grade and lay a foundation into today's topic. Right. In grade 6, we talked about mains electricity, right? This is the first topic that lays a foundation to today's topic, right? We talked about mains electricity. Then in grade 7, we talked about the supply system. In grade 8, we talked about the energy transfer in electrical systems. Not only that, we moved on to grade 9 where we talked about the national electricity, right? Talked about the national electricity. We talked about electric cells, and also we talked about series and parallel circuits. Right. So now let's look at our baseline assessment, right? So let's go through the questions together. Then after that, I'm going to give you some time to answer these questions. Number 1 is saying, what is electrical power? Number 2 says, what is a power rating? Number 3, what is the unit of measurement for electrical power? Then number 4, why do we need to know the cost of electrical power, right? So I'm going to give you 5 minutes to complete this activity, but please, after writing your answers, you can send in your answers, questions, or any comments on this lesson on our WhatsApp number, which is 079 Now let's meet again after 5 minutes. Welcome back, grade 9s. Now we are going to look at the solutions, right? Number one was saying, what is electrical power? So electrical power is the rate at which electrical energy is supplied, right? That is electrical power. The rate meaning how slow or fast what electrical energy is supplied. Number two, what is a power rating? A power rating is what? It's electrical power an appliance needs in order to work, right? Electrical power an appliance needs in order to work. That is power rating. Number three, what is the unit of measurement for electrical power, right? Electrical power is measured in units called watts or kilowatts, right? Watts having the symbol W, kilowatts having the symbol kW, right? It is measured in watts or kilowatts. Then number four, why do we need to know the cost of electrical power, right? This is because so that we can know how much money it costs to run various household appliances and save our electricity by using it wisely, right? So that we know how much money it costs to run what various household appliances and save our electricity by using it wisely, right? So this is all for our baseline assessment. Now I'm going to give you another minute to copy down the corrections. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now let's continue with our lesson. Right. We're going to start off by highlighting some of the important terms that we are going to come across, right? So that we understand this whole topic, right? So now, the first term we have there is electrical power, right? So electrical power is the rate at which electrical energy is supplied to an electrical device or appliance, right? It is the rate at which energy is supplied to an electrical device or an appliance. Then we have watt, right? W-A-T-T, right? That is the unit of measurement for power. Then we have power rating. And power rating is electrical power an appliance needs in order to work. Then we have kilowatt hour. And a kilowatt hour is the measure of the quantity of electrical power used. Then we have unit price of electricity, right? Unit price of electricity is the cost of electricity in rands or cents per kilowatt hour, right? It is the cost of electricity in rands or cents per kilowatt hour. Then we have tariff. And a tariff is the schedule of prices or fees used to charge for services, right? Whether it's water billing, electricity billing, and so on, right? So it's the schedule of prices or fees used to charge for services. Right. So now, before we talk about the cost of electrical power, we need to understand what electrical power is, right? So basically, electrical power is the rate, right? How slow or fast, right? the rate at which electricity is supplied to a device or an appliance, right? How fast or slow a certain appliance receives electrical power, right? How slow or fast a microwave receives electrical power altogether. How slow or fast a refrigerator receives power. That is electrical power, right? That is the rate at which it is supplied to a certain device or an appliance. Are we together? So now, electrical power is the amount of electrical current that is flowing through a system because of voltage, right? So as it is flowing through a system, what is happening? We're looking at the rate at which it is flowing in, right? We're looking at the rate at which it is flowing in into a microwave, into a refrigerator, into a stove, or any electrical device or an appliance altogether. That is what electrical power is, right? So just a reminder here. We remind you that current is the rate at which electrons flow through a conductor, right? And also we're talking about what here? We're talking about the amount of electrical current that is flowing through what? A system because of voltage, and we're looking at its rate, right? So all in all, we're talking about electrical power here. Are we together? So now, voltage, right? Voltage is the force with which electrons are pushed through a conductor, right? So electrical power is measured in units called watts or kilowatts, right? So when talking about electrical power, the rate at which the current moves into a system, electrical device, or an appliance, right? We're talking about what? Electrical power that is measured in units called watts, right? Or kilowatts. The watts, I have a symbol of W, whereas kilowatts are symbolized by kW, right? So now this unit of measurement indicates how much electrical energy is being used per second, right? So as you plug on that kettle, as you plug on your microwave, as the fridge is running as well, right? These measurement, kilowatts and watts, right? They indicate how much electrical energy is being used per second, per minute, per hour, per day, per month, right? So that we can determine the cost of electrical power, so that we can be able to pay for electricity in the correct way, right? So now, for example, here, a 100 watts light bulb will use a lot more energy each second than a 20 watts light bulb, right? Same as different kettles, same as different irons for ironing our clothes, right? They will all use different watts per day, right? So meaning what? The more the watts that have been used, the more that we have to pay, right? So this unit indicates how much electrical energy is being used per second, right? As we have given our example here, right? And please note that all electrical appliances use electrical power to work, right? So now the power rating of appliances can be determined by looking at the back panel of the appliance, right? So for instance, here we have a kettle, right? We can look at its back panel for us to be able to identify how much power it uses per second, per minute, per day, and so on, right? So looking at this one here, right? We have the brand name, we have the model number, and also we have some information here, right? The amount of voltage, and here is the information we're looking for, right? So this kettle here uses what? Uses 2520 to 3000 watts to work, right? To operate. That is the power rating of this what? Of this kettle, right? It needs such amount of power for it to operate. So if an appliance uses a lot of electricity, we measure the power consumption in thousands of watts, right? And thousands of watts are known as kilowatts, right? So this one we apply when an appliance uses what? A lot of electricity. So we can measure the power by converting the watts into kilowatts. Are we together? So now, as we know that sometimes we go and buy electricity, sometimes we receive electricity bills at our houses, right? So consumers pay for the power they use, right? Hence, we need to talk of the cost of electrical power, right? So consumers pay for what they use, right? So while a household appliance is working, it will be using electricity at a certain rate measured in watts, right? As I said, that when you plug in your kettle, it needs about 2,520 to 3,000 watts just to operate, right? Are we together? So also it uses what? The electricity at a certain rate, right? Also depending on the amount of times and hours that kettle has been used for, right? Also depending what? On the amount of time that microwave is on for, right? And also the certain rate is measured in watts, right? So for us to be able to calculate how much that costs, right, we need to measure how many watts are used over a period of 1 hour, right? Also, we call this a kilowatt hour, right? The measurement of what? Of how many watts are used over a period of 1 hour, right? That is a kilowatt hour having the symbol kWh. Sorry, kWh. Right. So this means that if you run an appliance rated at 1,000 watts or 1 kilowatt for 1 hour, then it means that you will have used 1 kilowatt hour of electricity, right? So if what? If you run an appliance rated at 1,000 watts or 1 kilowatt for an hour, so it means you will have used what? 1 kilowatt hour of electricity, right? So how can we measure electrical power now? So electrical power, as I said, it is measured in units called watts or kilowatts, right? So 1,000 watts gives us 1 kilowatt, right? So we need to be mindful of these conversions, right? So sometimes a question can require you to move from kilowatts to watts or from watts to kilowatts, right? So in order for us to get kilowatts, we need to divide the amount by 1,000. Why 1,000? Because what? 1,000 watts, they give us 1 kilowatt. Are we together? Hence, we need to divide by 8,000, right? So also, if we are moving from kilowatts now to watts, it means we're going to do what? To multiply by 8,000. Are we together? So now, let's look at this example here, right? We're going to look at an example of a geyser, right? So a geyser with the following information, right? We need to convert the watts to kilowatts, right? So here is the information of the geyser. We have the geyser here. Then the information, we have the equipment, the brand name, the model here, the capacity, which is 6 liters, then rated power, which is what we are looking for, right? The rated power of this geyser, it is 3,000 watts, right? Meaning what? This is the amount of energy or power it needs in order to be able to operate, right? So now I'm going to ask you for you to simply convert these 3,000 watts into kilowatts, right? Just a minute to see whether you understand, right? Let's just take that minute, try and convert these 3,000 watts to kilowatts. Welcome back, grade 9s. I hope that was easy, right? So remember, 1,000 watts gives us what? 1 kilowatt, right? So meaning if you need to move from watts to kilowatts, what do? We divide by 1,000, right? But if you need to move from kilowatts to watts, we multiply by 1,000, right? So I said for this one, convert these watts to kilowatts, right? So this is how you should have done it, right? 1,000 watts is equal to 1 kilowatt. So 3,000 watts for this geyser, divide by 1,000 watts per kilowatt. What does it give us? 3 kilowatts, right? It gives us 3 kilowatts, right? So that's how we convert from watts to kilowatts, or from kilowatts to watts, right? So now, 1 watt of power is equal also to 1 joule of energy supplied in a second, right? We need to note that down as well, right? 1 watt of power is the same as 1 joule of energy supplied in a second in a system, right? So 1 watt is equal to 1 joule per second, right? So meaning what? If you're using 2 watts per second, you're using 2 joules per second. 5 watts is the same as 5 joules per second as well. Are we together? So now, let's quickly engage in activity 1 and see how far we understand. Number 1 says, what is electrical power? Number 2, what is the unit of measurement of electrical power? Then number 3, you need to copy and complete this table, right? It says this table shows different ratings in watts, so convert each one to kilowatts, right? You have 3,000 watts, 2,200 watts, 1,500 watts, 800 watts, and 12,000 watts. Convert all of them, each and every one of them, into kilowatts, right? So I'm going to give you 5 minutes for this activity. Then after that, we shall mark together. Welcome back again, grade 9s. Now let's look at the solutions. Number one, what is electrical power, right? So electrical power is the rate of electricity supplied, right? Or rate of electrical energy supplied. And number two, what is the unit of measurement for electrical power? It is measured in kilowatts or watts, right? Then number three, this table shows different ratings in watts. So convert each one to kilowatts, right? So now, starting off with the first one, right? The first one now is 3000 divided by 1000. It gives us 3 kilowatts, right? You mark your work. Then 2200 watts divided by 1000 watts per kilowatt. That is what? That is 2.2 kilowatts. Then 1500 watts divided by 1000 watts per kilowatt. That gives us what? 1.5 kilowatts. Then we have 800 watts. So it is 800 watts divided by 1000 watts per kilowatts. And it gives us what? 0.8 kilowatts. Then the last one, 12,000 watts, right? So 12,000 watts divided by 8,000 watts per kilowatt, that gives us what? It gives us 12 kilowatts, right? So I hope you enjoy this activity. I'm going to give you a minute again to copy down corrections. Then after that, we shall continue with our lesson. Welcome back, grade 9s. Do not forget to interact with us on our WhatsApp interactive number, which is 079-578-2908. So now let's continue together, right? We are still on the part of measuring electrical power, right? So we did highlight that consumers pay for the amount of power they used, right? So now, they pay according to what? According to what they have used, right? So an electrical meter is used to record how much electricity you have used, so that the company that is supplying the electricity can charge you the necessary cost, right? So here is an electrical meter. We often see also inside our houses, right? Doing what? Counting, right? The number of kilowatts you have used per hour, right? Which is the kilowatt hour, right? So also the quantity of electrical power that is used is measured in kilowatt hour or kilowatt hours, right? And also we can calculate the quantity of electrical power used by multiplying the power rating of the appliance by the number of hours it was used for, right? So it means what? We can calculate the quantity or amount of electrical power that is used by multiplying the power rating of a certain appliance by the number of hours it was used for, right? So electrical power, here is the formula. It is power rating of the appliance, right? It is the power rating of the appliance plus the number of hours you have used the appliance for, right? Let's look at some examples here, right? Like the LED light bulb, right? It has 18 watts, right? So in order for us to get the kilowatt, it means we're going to say 18 divided by 8,000, right? 18 divide by 8,000 to give us what? 0,018 kilowatts, right? So if we have used this LED light bulb for 2 hours, so we're going to multiply it by 2 hours, right? So multiplied by 2, it will give us what? It will give us 0,036 what? Kilowatt hour, right? That's how we calculate for what? For the power rating, right? So like this one here, the LED tube light, also you do the same, 35 watts, right? You multiply by the number of hours it was used for, right? The ceiling fan as well, 75 watts, you calculate by the number of hours it was used for, and so on for all these other appliances, right? Washing machine has 2000 watts, multiplied by the number of hours it was used for. Air conditioner, it has what? 8000 watts, multiplied also by the number of hours it was used for. Right. So now, we can also calculate the cost of electricity to the consumer, right? How much will it cost per month or for the amount of electricity used, right? So the cost is calculated by multiplying the power rating of the appliance by the number of hours it was used for, multiply also by the unit price of electricity. Are we together? So meaning what? From the formula that we were using in the previous slide, you do the calculations, then you multiply by the unit price of electricity, right? So if the unit price of electricity is 2 rand 70, for example, so meaning you're going to do what? You're going to do power rating, right? You're going to do power rating, right? Multiplied by what? By the number of hours, right? Multiplied by also the cost price or the unit price of electricity, right? That's how the formula goes. Right. So as the formula comes back now, right? It is cost is equal to power rating multiplied by the number of hours used, multiplied also by the unit cost of electricity, right? And the unit price of electricity changes every year, right? So in South Africa, our electricity unit charges work on a sliding scale. So what does that mean, right? So it means that the cost of electricity increases at certain intervals as you use more electricity, right? So we can also load money on our prepaid electricity cards to help us control and understand how much energy we are consuming and how much money we need to spend on electricity. So now, let's quickly look at activity 2, right? Copy and complete the table below, right? The table has appliances, power rating, and the number of days or hours, right? Also the number of hours used per day, right? So you need to calculate for what? You need to convert the watts into kilowatts in terms of power rating. Then you tell us what? The power used per day in kilowatt hours, right? For each and every appliance. You are given the appliance, you are given the power rating in watts, and also you are given the number of hours. You only need to give us what? The kilowatts and the kilowatt hours. Are we together? So let's take 5 minutes to copy and complete this activity. Then after that, we shall move together again. Welcome back again, grade 9s. Now let's look at the solutions together. Copy and complete the table below, right? So let's look at the television. The television has what? Power rating in watts of 140, right? So the power rating in kilowatts is what? It is going to be what? 0.14. Why that? Because 140 divided by 8,000, it gives us what? 0.14 kilowatts, right? So we continue like that, right? For radio, the kilowatts are from 80 watts divided by 1,000, it gives us 0.08 kilowatts. Then for electric iron, it has the rating power of what? Of 2,200 watts, right? So the answer is 2.2 kilowatts. Then the toaster has the power rating of 1,500 watts. Then in kilowatts, it is what? 1.5 kilowatts. Then the kettle has 2,200 watts. So in kilowatts, it is 2.2 kilowatts. Electric carving knife, it is 120 watts. So in kilowatts, it is 0.12 kilowatts, right? Then the slow cooker is 320 watts, right? Then it is what? It's going to be, it is going to be 0.32 kilowatts, right? So since we have converted all of these into kilowatts, now let's calculate what? Let's calculate for the power used per day. Using what? The number of hours used per day. So now 0.14 multiplied by 6 for television is 0.84 kilowatt hour. For radio, it's 0.08 multiplied by 2 to give us 0.16, right? Then for electric iron, it is 2.2 multiplied by 0.5. It gives us what? 1.1 kilowatt hour. Then the toaster, 1.5 multiplied by 0.2, that is 0.3 kilowatt hour. Then the kettle, it is 2.2 multiplied by 0.5 to give us 1.1 kilowatt hour. Electric carving knife, 0.12 multiplied by 0.25 to give us 0.3 kilowatt hour. Then slow cooker, it is 0.32 multiplied by 12 to give us 3.84 kilowatt hour, right? So I'm going to give you also another minute to copy and complete these corrections. Then after that, we shall move to the last part of our lesson. Right, welcome back, grade 9s. Now let's move on together. Right, so we said that we can be able to calculate for the cost of electrical power, right? So now, to use prepaid electricity cards, we need to have a prepaid electricity meter, right? That can give us information in terms of how much power we have used per kilowatt hour, right? So our meters are something like this. They keep on counting the energy that is used in the house per day and per month, right? So once a month, households receive an electricity tariff account that states how much their electricity usage has cost for that month, right? And we call such as what? A bill, right? An electricity bill. So it looks something like this, right? There's all the details in terms of what? Sometimes they are combined. It can be a water and electricity tariff at the same time, right? It gives us all the information in terms of how much per unit cost, right? How much did we use that month and how much we need to pay towards the supplier of these services, right? When you look at this example here, this is the total due for a month, right? Meaning this is going to be the bill for the month, right? So one needs to pay 1,255 and 6 cents to cover for electricity bill, right? So as the quantity of power used increases, so does the unit cost, right? And we said that that is what? A sliding scale, right? So electricity in South Africa also increases every year, right? Because of this sliding scale, right? So a management levy or service charge, network charge, and VAT charges are also added onto the cost of electricity, right? So now we are going to engage on our last activity now, right? Then after that, you're going to summarize what we have learned for today. Right. It says arrange the appliances in order from those that use most power to those that use the least power per day, right? So we're going to use this table alongside here. Then number 2, which appliance is used for the longest time during the day? Number 3, which appliance is used for the shortest time during the day? Then number 4, which appliance do you think costs the most every day given the time that it is used for? Right? So I'm going to give you 4 minutes to copy and complete this activity. Then after that, we shall wrap up our lesson. Welcome back again, grade 9. Now let's look at the solutions. Number 1, arrange the appliances in order from those that use most power to those that use the least power per day. Right? So here is the sequence. We start off with the slow cooker, electric iron and kettle because they are the same, television, radio toaster, and electric carving knife. You mark your work. Number 2, which appliance is used for the longest time during the day, right? And that is the slow cooker, right? It is used for the most number of hours, right? Then number 3, which appliance is used for the shortest time during the day, right? And that is the toaster, right? Then number 4, which appliance do you think costs the most every day given the time that it is used for, right? And that is the slow cooker, right? Because it is used for a long time, right? So now we are going to move on to our WhatsApp section, and it seems like there is no WhatsApp questions today, right? So we are simply going to summarize what we have learned for today, right? So today we're talking about the cost of electrical power, right? We say that it is the rate at which electrical energy is supplied to a device or an appliance. Sorry. Also, we talked about the fact that electrical power is the amount of electrical current that is flowing through a system as a result of voltage. We said that also electrical power is measured in units called watts or kilowatts, right? And also we said that all electrical appliances use electrical power to work, right? And we said that the power rating of appliances can be determined by looking at the back panel of the appliance. Also, we said that yes, it is measured, electrical power, measured in watts or kilowatts. Also, we said that 1000 watts gives us what? 1 kilowatt, right? So if we were to convert between the two, right? Meaning moving from watts to kilowatts, we're going to divide by 1000, and moving from kilowatts to watts, we're going to multiply it by 8000, right? And we also highlighted that 1 watt of power is equal to 1 joule of energy supplied in a second. Also, we highlighted that consumers pay for the quantity of power they've used, right? And we use an electrical meter that records how much electricity you have used so that the company that is supplying the electricity can charge you the necessary costs, right? And we said that the formula is for electrical power used is power rating multiplied by the number of hours, right? And also highlighted that the unit price of electricity changes in every year. And in South Africa, our electricity unit charges on a working slide. Sorry, charges work on a sliding scale, right? And also we said that we can load money on our prepaid electricity cards to help us control and understand how much energy we are consuming and how much we need to spend on electricity, right? So I'm going to give you the last minute of the day now to copy this homework activity. Then after that, we're going to say our goodbyes. Welcome back, grade 9s. Now we are going to wrap up our lesson, right? So please remember that this was our last lesson for this term. So we're going to meet again next term when we are discussing planet Earth and beyond, right? So from me to you now, thank you and goodbye.